Hello there, today we'll be doing container with most water. Let's check out this particular problem. In this particular problem, we are given a bunch of heights. With these heights, we're trying to find the maximum area within it. And so the maximum area here is 49 because we have a width of 7 and the height of 7 between the two containers. So we're looking for the maximum height and width. So suppose we have a left pointer and right pointer on both sides. At this particular point, our left pointer is at 0, and our right pointer is 1, 2, 3, 4, 5, 6, 7, 8, at 8. So our distance is currently 8 width. And our height is equal to the minimum between the two, which is going to be 1. So 1 times 8, our result area is going to be 8 times 1, which is 8. Of course, as we're going to move the smaller one to a bigger the item, because we don't want to use the smaller item. We want to get a bigger item so that we can get bigger, because we know that we're reducing the width as we move on. So width is now going to be 7. So with that, what's going to happen is 8 minus 1 is 7. And now 7 times, get the minimum height between the two is going to be 7. And we're going to have a maximum height of 49 at this point. I mean maximum area. So at this point, we of course our area is 49 for this one. We're going to move the 7 down to see if we get anything bigger. Of course we don't, and our width is now reduced to 6 because 7 minus 1. Our height our width is reduced to 6, 7 minus 1, and our height is reduced to 3, which is going to give us an area of 18. Of course, we're going to move, because 3 is smaller than 8, we're going to move the right down to 8. So 8 and 8, we're going to have a height of 8 and a width of 6 minus 1, which is going to be 5. 5, and then 5 times 8 is 40. 40 is still not bigger than 49, so we're keeping that. Whether or not which one's bigger or smaller, let's just move the left one. 6 times 8, 6 times, yes, 6. We have a minimum height of 6. And our width is getting smaller and smaller. We only have a 4. So with each round, looks like our width is getting smaller by 1. So we can record a minimum width and reduce it by 1 every turn, or we can just do a right minus left, which also works. I think we'll try both ways to see what happens. So let's make a note of that. Try both right minus left and record with minus equals 1. Okay, so with that note done, we're looking at the smaller one and we're moving it. It looks like we have a 2. So we have a height of 2 and a width of 3, and that's going to be 6. And then we moved left again. We have a 5 and a height of 5 between the two, and the width of 2. That's 10, and then we have the last one. Left is 4, 4 and 8. Well, at this point, we know for sure it's going to be 4, the height, and the 1, so that's going to be a width of 1, so that's going to be 4. And the maximum area, as we pass by, these two are now equal. Our max area is 49. So let's put this into practice and see what we get. All right. So first things first, make sure we record the results equals 0 right now. We're going to set our left and right is equal to 0 and length of height minus 1 to get our last item. Let's set our width to 2 this time. Width is going to be, well, I think the maximum width was length of height minus 1. So that's going to be 8. Yeah. Okay. So while left is less than right, we're gonna do if well, let's gonna get the left height and the right height, left height and the right height equals height at left and height at right. All right, let's get the width. The width is equal to the width, of course. We're gonna move the width minus equals 1 at the end. We're gonna do if left height is less than the right height, then what's gonna happen is left plus equals 1, else right minus equals 1. With that, we're good with the incrementing, and will not fall into infinite loop. Let's get to the max area part of the formula or function. Well, area is equal to height times width. So the minimum between left height and the right height times well, the width, and well, the results equals the max between the area and the results. Let's return the results and let's see if this works okay. All right, looking good. Let's check it out. Okay, it looks pretty good. It's a little slow. Let's try to remove the width and see what happens. So we're gonna remove the width and generate the width every single time. So minus left and remove this line. All right, let's run it. Okay, it's slightly faster for some reason. Maybe it's one extra variable. Maybe. I'm not sure exactly what it is that is causing this difference. Let's return it to the original state and see what's going on. Submit again. Yeah, it's much slower. What does it have to do with? I'm not sure exactly what it is. I mean, all we're doing differently is holding a different value in memory and altering it. I'm not exactly sure what's going on. Why is it much slower? Let's run it one more time. Make sure it's not a fluke. And, well, it looks like it's a fluke because it's much faster now. Okay, well, let's think about this. In which way will we be better to able to remember this particular problem? Do we want to think about the width or not think about the width? I think we don't want to think about the width and just record it and minus equals 1 every single time. And that helps us think, like have less logic to think through. Also, length with result can we put the result on the same line? Would it make it hard to read the code? I think yes. It would make the code harder to read. Okay, so also the width on the same line of left and right is harder to read. So we're gonna set the width to be here instead because on the same line it's just a little bit harder to read. So we know what we're doing. We have left height, right height. I think everything looks good. Minimum height times the width. It tells us the story about what's exactly happening and with how we're incrementing the left and right pointers based on the height, and the height width is reducing every single time. I think this looks good. Okay, so I think this tells a pretty good story the next time we read the code, and it tells us how to work with left and right pointers. to generate the maximum area at this particular point for this particular problem. So if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much and have a good one.